Hey guys, something a little different in this video. I want to have a little bit of fun, take a break from the predictors that I've been working on in the background that you will be seeing more of soon, and take a little break before I launch into some heavy-duty projects that I've been teasing in a bunch of recent initial checkout videos. Well, I also did an initial checkout video on this little guy. It's a 7-inch portable Motorola TV from 1949. Well, the owner decided to not invest the money to get it restored. But I liked it, so I worked out a deal with him, and it's now mine. Now, in that initial checkout video, it was determined that it was all original inside, all the original caps. Tubes had been replaced, but all the rest of it appeared to be stock, and it was able to produce a raster. So I want to go and see what will it take to produce an image and sound with this set, and do it methodically, try to use a little bit of troubleshooting and some common sense and some intuition. I also want to try using adapter caps. When I first saw them, one of the first things I thought of was this chassis, because it has 3 electrolytic caps mounted on phenolic insulating wafers, just like the adapter caps. And it's in a congested area, and it's always a headache when restoring this chassis. So I have high hopes it's really going to make it an easier and less error-prone process. So let's get started. Now, I already had pulled the chassis on this. I didn't fully reassemble the set, so it should be pretty easy to get it apart. Notice I have a towel underneath the set. Highly recommend you do something like that if you're going to be sliding a set around, even though I have... These are actually carpet samples. I've tried them both ways. It's nice to have the soft side up, the carpeted side, to cushion things. But when you're soldering or clipping component leads, they tend to get tangled in this fabric really quickly. So I've tried using the back side. It's not exactly heat proof, but solder blobs you can pick off. But it's not as cushiony, so that's why I have a towel between the two surfaces. Let's see, I remember I did reconnect the speaker when we left off, so disconnect it again. There's 2, and the CRT. So when I pulled this off initially, even though I was really careful, I did pull one of the pins off the CRT. I did solder it back on, but it just came off again. So that's definitely one reason why I want to use an oscilloscope CRT and leave the rest of this alone, so I don't cause any more damage, because this is a good CRT. 7JP4s are not rare by any means, but so many electrostatic sets use them that they're in high demand, because these are very collectible sets. A ton of sets, different makes, different models, use the CRT. All of them are collectible because, well, they tend to look cool, and they're small enough that you can collect them and store them and have a bunch of them without taking over your house. Alright, so that will all be put away for quite a while. We're going to focus on what's left. So, and we'll get out. Looks like I pulled out 2 pins from the CRT. Wonderful. Common issue. Well, I got to dig a pin out of this, and then I'm going to get that green CRT. Interestingly, on eBay, there's at least one seller that has both plugs and sockets. They're not cheap, they're 20 plus bucks a pop, but if you really wanted to replace the base with one that had just really good pins, or needed to replace this, they are out there. Other CRTs use them, some early oscilloscopes did, but also photo multipliers did. And I've heard early color TVs did too. I don't know that for sure. The 15GP22, the first color CRT, may have used a 14-pin socket, but I know it had a special area for the high voltage focus pin, so I don't think it would exactly fit on this. Anyways, I'm getting way off topic. So here's what we have to work with. I've worked on so many of these, this is just burned into my mind. Here's the high voltage caps. This particular flavor, this chassis had a bunch of revisions. This flavor has 5 high voltage caps. 3 of them are 0.0047. 2 of them are 0.001. The smaller caps are for horizontal deflection. 2 of the larger are vertical deflection, and the third one, or fifth one, is for filtering the high voltage. High voltage generated inside this box. RF oscillator driven by a 25L6. This is self-contained high voltage generator in here. Let's flip this around. This is your RF front end. This is crude stuff. It's just a wafer switch for the channel selector, 8 position. You set the local oscillator and bandpass filters with all these adjustable coils. So you see there's 8 positions, so we have 8 here and more here. Hopefully we won't touch those. Let's see, I think that's the RF amp, that's the local oscillator mixer. A few IF stages. The detector is actually a really super early 1N34 germanium diode inside this box. It may very well be bad. A 6AU6 video amp. These are our deflection amplifiers, some 12SN7s and a 6SL7, and this is our audio stuff. Ratio detector, 6AL5 dual diode, and 12SN7 for first audio amp, and then another 25L6 for the final audio amp. That's our ballast tube, and these are the 3 electrolytic caps that I want to replace eventually. Inside of this, I think is the horizontal or vertical oscillator coil. So I think it's the vertical maybe, and I think this weird looking blobby thing is the or maybe that's the horizontal. And that blobby thing is the vertical. That part I don't remember too well. And we have other assorted paper caps, but there really aren't that many. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 or 19, 5 of which are those special high voltage ones. Which isn't too horrible. And there's our 2 selenium rectifiers. Okay, so let me get out my green scope CRT and we'll fire this guy up again. Alright, here's what we have now. It's a chassis. A 7VP1 or 7JP1 has been installed. Exactly the same as the 7JP4, only it has a P1 phosphor. That's the green phosphor, common on early oscilloscopes. I put a little bit of padding under the neck of the CRT. It's glass. This is metal, and we have high voltages involved. If you just let this rest right on the surface, there can occasionally be arcing between these surfaces. And I have a compatible Motorola speaker plugged in. It's a Class A audio output stage. Generally not a good idea to run these without any load. Now, series strong set, but the chassis is actually floating. It's not hot. It's not grounded either, so definitely a good idea to use an isolation transformer no matter what. So here we go. I'm running it through a Suncor PR57 isolation transformer / variac. It's dialed into about 115 volts. The set was designed for 115 to 117. Turning it on. I'm going to switch this to current mode so I can see how much current we're drawing. We're drawing about an amp. It's dropping. Turning some of the lights down. Turn the volume up. I have no signal injected right now. I will once we confirm we have a raster, and we do. This is safe to do. This is glass. It's not. I'm not going to get shocked or anything. Let's see. Here's the intensity control. It's up all the way, so it's not exactly very bright. But we do get some kind of static. It does. This is the contrast control. It does something when I adjust the controls, so that means there's some kind of signal getting through it. Alright, I'm going to dig out some of the knobs so I can manipulate things. and I'll feed a signal in. Now, I notice the screen is off to one side and kind of too large. Yes, there are controls that can adjust that stuff, but I also suspect the leaky caps are kind of affecting the deflection functionality. Okay, now the signal being fed in, as usual, red Solo cup to hold all the parts so we don't lose anything. There's a channel selector, fine tuning. So this is where I got before when I played around with this set. Kind of seems like it's doing something. One of you suggested it might be dirty control, dirty switch tuner. Maybe. I think there's a little bit more going on here than that. Alright, so normally the first thing I would suspect is electrolytic caps, and it's the B plus is too low and all that. But we do have okay intensity. It should be brighter than that, so I don't think we have full power going to the set. I think the caps are maybe leaky and dragging it down. But it's pretty good. It is filling up the whole face. And the tuner's doing something. So there's an early germanium detector diode that could be bad. I've certainly seen that in a couple sets. But before we dive into anything complicated, let's do the simplest thing possible and just check some of these front end tubes. Now, since we don't have sound or video, we can isolate it to this, because the set is not split carrier. The sound and the video both all go through these tubes. So let's check these tubes. That would be, I think, a 6AG5, a 12AT7, and some 6AU6s, all very common tubes. Now, when it comes to checking tubes for a TV, we don't need to check for mutual transconductance. We don't need matched pairs. We just want to make sure the tube isn't dead and doesn't have any shorts. And it turns out in this flavor, it's all 6AG5s on the front end, no 6AU6s. 6E. So I'm using a Suncor TC162, which is a very sensitive shorts tester and grid leakage tester. It's just an emissions type tester. 6E146, E1, and the number 4 socket. These tubes are all sorts of... Every tube is a different brand. Well, no, we have two Kenrads, we have an RCA Victor, we have two other RCAs, but they're very different vintages. Originally, these would have all been Motorola branded. Those are all long gone, so the set has seen some use. For shorts, we just rotate through this. And we don't have any. Let's see. And emissions are good. And grid leakage is fine. Alright, so on to the next one. Don't have a tube tester. Since we have 4 6AG5s, you could just swap them around in different positions, or pick up another couple spares and try swapping them in. Well, all 4 of the 6AG5s tested fine. I tested the 12AT7, and I checked the 2 6AU6s after the video detector, and for the sound IF, no problem. However, just by virtue of me pulling them out of the sockets and putting them back in, may have knocked off some dust. there can certainly be issues with contact corrosion. So this might have made a difference, or by me swapping the tubes around. Or not. Oh, wait, hey, those are the credits for Star Trek Enterprise, I do believe. So, let's see if we can actually see anything. Yeah. Let's see. If I reach around the back and not electrocute myself, can I find vertical and horizontal hold? Let's try to focus as well. Height and width. Alright, so now we have a different issue going on. Looks like we are actually receiving this. There'll be a little bit of the Baywatch theme. So let's get the contrast up. Try to turn this brightness down. Now we have issues with the sync. Is way off. And probably the gain for the video. I'll try the converter box in a different channel. You can do 3 or 4. No. There's another potential issue. I don't know what channels the set is tuned for. Okay, that's coming in better. We have okay sound. Again, try the vertical and horizontal hold on the back. Okay, so horizontal's definitely off. You can tell that because of these diagonal horizontal lines. Interesting. So, let me check the rest of the tubes. I think we might actually be closer than I think about this set actually kind of working. Well, basically all the tubes are good, so we need to look elsewhere. So, I want to start going underneath the chassis. Now, I'm going to work commando style, meaning no service info. One, because I'm fairly familiar with this set, and two, because it's all original, so I can read the component values off of the components. So we kind of have reception, we definitely have deflection, we have high voltage, we have audio. What we don't have is synchronization. So I want to focus on that circuit. And where does that take place? It takes place after the video amp, after the detector. There are 3 12SN7s towards the back here. Those are involved in the sync circuits, or at least 2 of them are. So I'm going to focus my work on this area back here. And I'm going to start out by replacing a few of the caps. I may reference the schematic just to make sure that I'm actually working on a sync tube and not something else. But that's where we're at. The set turns on. We have a raster meaning horizontal vertical deflection. We have light on the CRT. And once you have that, the CRT is an excellent troubleshooting tool. So, in other words, and so is the speaker. So we can hear we have sound. We know the tuner's working. We know we have receptions. We know that the local oscillator, the mixer, the detector, the IF, all this stuff is working. We can ignore that for now. We have vertical and horizontal deflections. So we can ignore the deflection amps. What we don't have is synchronization, meaning that it's not locking. The signal is just drifting all over. And I think that the video amp is also a bit weak because we're not getting really strong distinction, I think, between the lights and the dark area of the image, but that's hard to say when the sync is this far off. So let's focus on the sync circuitry. Well, I suppose it'd be a little foolish to go in without any service info, so let's take a gander at a Wallace Tele-Aid. I picked a bunch of these up a few years back. These are spiral-bound volumes, bound by manufacturer and by year. So this covers 46 to 51 from Motorola. Most of this is just a large form factor schematic for each chassis and chassis revision. It doesn't have detailed alignment info or set info or assembly disassembly instructions or a detailed parts list. It's mostly, I find handy because it's a large, easy to read schematic. So we want to look at the sync circuitry. Well, here's the converter, IF amp, detector, video amp, and this stuff. They call it a clipper. This is going to be part of our sync circuitry here. Those 12SN7s I was talking about. So V10 A and B, 2 sections of one 12SN7. So let's use some common sense here. What's typically bad in old radios or TVs? The paper caps, they get leaky. We will also double check the resistors. But what jumps out right at me on this, we have 2 0.05 microfarad caps. So let's go after those, because this circuit feeds both the horizontal and the vertical. We can't lock either one of these. What's the common point? Right there. And what does that go to? This circuit. This circuit comes off the video amp. So we kind of have reception, we kind of have sound. So we can figure this stuff is more or less working, but we can't sync. So let's go and check out this stuff. Now, what do I mean by check out? Yeah, we could disconnect one leg of each capacitor, check it for leakage. I've been doing this a long time. I've checked a lot of caps. I can tell you right now, they will all test bad. They will all be leaky. The thing is, though, there's leakage and then there's leakage. In other words, some caps can be leaky, but the circuit will still function. In particular, caps that are used for bypass. They're there to filter out noise on a power supply rail, for example. They can be leaky and it still works fine. A coupling capacitor. It might be rated for 600 volts, but there's probably very little DC voltage across it, so it really doesn't matter. What typically does matter a lot is timing circuits. If you have a leaky cap on a timing circuit, a circuit where the RC time constant is critical, that's going to be a problem. That's what I want to check out. I believe those caps are down in here. So here's a 0.05 here, and there's one there. Those may very well be, like I said earlier, there aren't very many caps. You know, these are the high voltage caps. This is the IF stuff and AGC. And there's a 12SN7 right there. That's the video amp. So I want to replace this guy and this guy and see what difference it makes. I ended up replacing 3.05 microfarad caps because the initial one I replaced turns out to be a coupling cap for the video amp to the CRT. These are the two that I meant to replace. And this may seem odd to some of you, but I'm really torn about working on this set. It's so original. I almost feel like it's sacrilege for me to be doing anything to it. I took a ton of reference photos. I may very well go back and restuff these caps. Every single one of them is branded Motorola. They're all the originals. The set has never been worked on. On the other hand, it's not an uncommon set. It's not a valuable set. You just don't find them like this that often. So, what to do? Anyways, I've already taken a plunge, so it's not original anymore, so we've already crossed that bridge. So let's try powering it up and see if this made any difference. There we go. Okay. We still have our reception. We still have sound. The question is, can we get a lock now? So this is vertical. It's got to be. It seems like that's kind of locking, or maybe locking, but the horizontal is definitely off. That's why we have all these striations horizontally. So let's go after the horizontal next. So let's go after the horizontal. What do I suspect next? Well, we have a 0.03 and a 0.5 microfarad. Those are fairly large values. Now, the larger the value of the cap means there's more turns of foil and paper, meaning it's going to be more leaky, very likely. More surface area, more leakage. So let's go after those two. Where are they going to be on the chassis? Well, let's zoom in a bit here. They're going to be down in this area. That's probably the 0.5, and the 0.3 I think is one of these two guys. It's probably this larger one. So let's go after, I think, those two caps next. Okay, the new 0.5 and 0.03. I really wish they made these Mallory M150s still. But nowadays all you can get are the yellow axial. Anyways, I'll flip it down and let's power it up again. It seems like it's getting really close. It's getting kind of hard to tell what's going on, to be honest. I think the horizontal is actually locked right now. I'm playing around with the vertical right now. It seemed like it locked there for a second. Vertically, that is. Yeah, right about there. We're kind of locked. I mean, it's there. That is a video image. It's just really bad. So, I think we might be back to just the general issues of the power supply voltage being too low. As I mentioned earlier, it should be brighter and the focus should be sharper. So, the B plus is probably too low. And why would that be? Not just leaky paper caps, not just bad electrolytics. We also have two selenium rectifiers we're dealing with. They tend to get less efficient with age. You do not ever want to experience one going bad in your presence because they smell really bad. I'm going to tip this up now. I've turned this off. There's no power going to it. I want to see if they're warm. They are a little bit warm. They're up here. So it's not just an issue of them going bad, it's an issue of when they become less efficient, they pull down the B+. So I want to go ahead and just measure it. It's between probably electrolytic caps that are not up to spec and these seleniums not being up to spec. I suspect the power going to the set is less than it should be. Well, there's really just no getting around it. We should have about 225 volts at this point. We only have 175. This is on the main power supply for the whole set. I'm going between ground and a point right after the rectifiers and filters. So we have significant loss. And I'm actually putting a little bit more line voltage into this set that it was designed for. So we have to work on the power supply. I replaced one of the caps so far with an adapter cap. That is the main capacitor for the voltage doubler coming right off of the ballast tube. Just a single section cap. And things have improved, believe it or not, a little bit. I can basically get a horizontal lock and a vertical lock, but there's a few other things going on. One, the horizontal centering is all the way at one extreme and it's still pushed over too far this way, which is a pretty good indication that there is a problem with one of the high voltage coupling caps. Also, the video is very, very smeared. I already replaced the 0.05 coupling cap from the video amp to the cathode. So this could still be a problem with the detector diode. It might not be quite as healthy as I assumed. So there's the cap I replaced, but there's also a 0.1 microfarad cap. I have not replaced that one yet. That could improve the video as well. So I'm starting to think now that, yes, the B+, it did improve with me replacing this one cap, but it's still a little lower than it should be. But I think we also have an issue with the video gain, which could be an issue with the AGC cap. There's a 0.2 or microfarad cap, I do believe, for AGC, or 0.25, I should say. That guy right there. C13. And that 0.1 microfarad cap I just mentioned a moment ago. All three adapter caps have been wired in. 2 seleniums replaced with diodes. Kind of see them, there's one there and one there. They're 1N5408 3 amp 1000 volt diodes. Way overkill, but I just buy them in bulk and use them for everything. So we're ready for another power up. Now if you're wondering, did I add resistors in series with the diodes? No. I'll tell you why. One, these sets seem a little starved for voltage anyways, so it doesn't really seem having a few extra volts is a big deal, but also there already is a resistor in series inside the ballast with the diodes, and there's a 200 ohm after this guy, so there already are existing resistors. Now when I rebuild the ballast, if I wanted to, if the voltage was a little too high and I wanted to knock it down, I could increase the value of that resistor and that resistor by, say, make that 47 ohms instead of 37, make that 220 instead of 200. I think it's a little better. So it seems like the horizontal is locked. So you can see when it's not locked, we get these diagonal horizontal lines. And as I turn the control, so I think it's locked right now. It just looks horrible. Like super smeared. Adjusting the focus control. It is not entirely focused either, which is going to have some impact. Alright, well, we continue. I think next I'm going to go after the detector and the video amp. That could very well just be really smeared video because the video amp is screwed up. Or I should say the signal's not being coupled cleanly. Here's another look at those adapter caps. I get it's not for everybody. After working on about 20 of these sets, that is by far the easiest and cleanest recap I've done on one of these. I'm not going to sugarcoat it. It is still tight quarters, and it's easy to misconnect a wire when working underneath. So you can probably see where this project is heading. That's the unfortunate reality of stuff, electronics that are this old. It'd be great to exercise some troubleshooting skills and do it methodically, but invariably I end up just recapping the whole thing to get it to work properly. The stuff is just, it's too old. All these caps are bad, and it's just not going to work right. I'll keep replacing them one or two at a time and powering it up, but I think that's where we're heading. So next up, video amp, which is that guy. We got some peaking coils, so let's get after that guy. 0.1 microfarad. I think that's pin 1. I think that's a coupling cap. Yeah, so that couples the signal from the detector to the video amp. And since our video looks like crap, let's try replacing that. We could also have out-of-spec resistors too, but experience tells me it's leaky paper caps. Replacing the video coupling cap resulted in no improvement. So I started playing around with the controls and was studying the screen while playing with the focus and the brightness and the width and the height and the centering controls, and nothing was really looking quite right. So I decided to just go ahead and tack in replacement high voltage caps. I have never seen one of these sets where these caps were still good, if the original caps were still good. Especially because the horizontal centering, I had it at one extreme and the picture still wasn't quite centered right. So I just went ahead and replaced these all, and well, let's see what effect that has. Alright, so here's my reasoning. It seemed like, well, not it seems like, we are getting reception. Horizontal and vertical hold are locking. But I wasn't able to really focus the CRT image right. Wow, that made quite a difference. Not for the better, but let's see what we can do with the controls. So let's start with focus. That's much better. Anyway, what I think was happening was, especially on that the high voltage filter cap, I think all the voltages in the CRT were just really off, and we weren't able to get a well-defined image. Let's see. Obviously, we need a little more height and width. Alright, width. There's height. Check out the centering controls. Get that over a bit. A little more brightness going. Get the contrast down a bit. And there we go. Vertical linearity is horrible. It's because I haven't recapped the vertical oscillator yet. Kind of lost the sound somewhere along the way, I noticed. Oh, it's there, it's just not very good. Alright, cool. It's nice to finally see some real progress. Cool. So let's see. How about next? Let's recap the vertical, so we can actually fix that vertical linearity, so people's heads aren't egg-shaped. A bit more height. Oh, also I have the height maxed out right now. It should be. I should have more height than this. So yeah, let's do the vertical next. I just went ahead and replaced the last few remaining paper caps. Let's see what we get now. So we had bad vertical linearity, and the sound wasn't so good. Well, the vertical linearity looks pretty good. Actually, we have, I think, a tad too much height. Remember, it's supposed to be 4 units wide by 3 high. So it might be a little more accurate. A little crooked. And pretty good sound. The volume control's a little dirty. We can take care of that with some deoxit. So, as I was saying earlier, it's the unfortunate reality of electronics when you get into stuff this old, be it radio or TV. There's really not much getting around. those pesky old paper caps. And in the end, that's all the set needed, was replace the caps. So I did save every cap I took out. I did take a lot of reference photos. I do intend to restuff this. All the caps I put in there, I just tack the ends in. It's not at all something I would put back into the cabinet. I didn't put any insulation over the leads. A lot of the leads are much too long. It could bump into something and short out, but it works fine. Didn't have to mess with any of the coils or anything like that. I do intend also to replace the original ballast. It gets really hot. That's why there's a sheet of asbestos inside the cabinet above it, which I'm not going to remove. I'm just going to leave it alone. As long as you don't crunch it up and let it become airborne and breathe in, it's fine. Just leave it there. Let's see what this ballast is for and why using pure resistors is not a good way to do this. So here we go. See how that glowed red? That is the ballast providing a soft start for the tube filaments. Pure resistors have the same resistance more or less regardless of temperature. The resistance on this varies with temperature, as do the tube filaments. The ballast provides a soft, it acts like a thermistor. So if you're going to replace it, if you're just going to use straight up power resistors, definitely add a thermistor on the AC line coming in. It will help save your tubes, especially the CRT, from repeated power cyclings of getting the surge current going through there. It can shorten the life of the filament. I removed the lid from my other example of this model for a little test run. Unfortunately, there is a bit of a color difference. Now, it still needs a little bit more cleaning. This might be stained with cigarette smoke or something, but I don't think it's going to change color that much. And this cabinet does have some damage on the side, so I might be better off keeping this lid with the other cabinet, maybe swapping the chassis into it. But for now, I'm not going to do anything drastic because the early television convention is coming up in a couple months, and maybe I can find yet another cabinet there. I would like to restore both sets if possible, but you also have to accept that not everything can be restored. But for sure, I'm going to make one good-looking example of this model. In the top would have been some antenna accessories. This would be a base. A metal base with a 3-foot-long bit of twin lead, and the actual antenna would have fit in here, went diagonally, had a 1/4-inch plug at the end. The antenna could either plug into the top of the set, or if you couldn't get good reception doing that, you could plug it into this base and then move it around on that long cord and position it where you could get best reception. I don't have the antennas. They're often missing. Occasionally they show up for sale. So, in fact, I think I might have a spare base, but I definitely don't have the actual antenna portion. But maybe someday. What is in really good shape, though, are the actual straps here. These are leather, and often the leather is cracked and deteriorated, but these are in really good shape. Okay, so I got the set working. It took less than an hour to replace the electrolytics using the adaptacaps. About 2 hours to replace the paper film caps. Took longer than it might have because I powered it up periodically. But it went faster, or went fairly quick on the other side because I just tacked them into place. Because now the real work is going to begin. What do I mean by the real work? Well, I mean the stuff that's not so fun. For example, 2 pins broke off the CRT base, and I suspect some others are loose. I need to deal with that. I'll try to repair this base rather than removing it and putting a new one on, which would be a lot of work. it needs a new power cord, so I need to get those rivets out, remove the stump of the old power cord, and install a new one. I want to restuff all the paper caps and reinstall them as close to the same position as the originals were, and do what I can to dress up the cabinet. Oh, and new feet. I did find some new feet that look to be exactly the same dimensions. Color's a little bit different. I haven't used them before, so we'll see when they will arrive next week. Now, that vendor also sells rack equipment, so I bought a couple rack rails so I can finally maybe assemble my home TV transmitter setup in sort of a custom enclosure. But I just bought the rails for now, so at least I can get the pieces assembled and connected up. And I did also find some little feet for the back side. So I'm going to break off here. Thanks for watching. The next installment will be all about restuffing paper caps.